Hello and welcome to episode 72 of the HamCorp training manual. In this episode, we will set up the Tesla tower to wirelessly transport power around our base. We will also craft the precise assembler and a neutron activator in preparation for the naquadah processing line. Before we continue with anything at all, I just want to say that my old design for automating the solar tower does not work. So my understanding of how the daylight sensor worked was completely wrong. It's not quite what I wanted. So I ended up going with the timer setup, like I mentioned at the end of the last episode. So this timer is set to 600 seconds, which is half of a Minecraft day. And I placed it and I set it up exactly at dawn, or rather exactly when the game turns from day to night, or from night to day. Now this timer ticks every 10 minutes and it flips a toggle latch. This toggle latch leads to my conduit. I was able to increase the amount of solar salt up to 7k, and I think I could also handle 8k now, and it would be quite stable. But I've had this going for several hours, and it's been very, very stable. This has been working almost flawlessly. So do this, or set up in a personal dimension. Now at this point, I have power sources in different places. So I have a power source here. I have a power source in the nuclear reactor, and of course I've got my burners in the main power building. I want the power storage in the main power building to be the central storage. So I want the nuclear to lead to that, and I want the solar to lead to that. And then from there, we power everything else in the base. That's a lot of crisscrossing cabling, which is not ideal. So a solution that I have is the Tesla tower. The Tesla tower is a pretty large multi. You can't really have more than one. Well, I guess you can, but they would all have to be configured the same way. Based on the primary Tesla windings that you use in the multi-block, it goes from LV all the way to ZPM, I think. Unfortunately, it doesn't go past ZPM, so once we get to ZPM and beyond, we'll have to reconsider how we transport power. But that's not going to be for a while, so I'm currently in LUV. So using these LUV superconductor primary Tesla windings, I can make a tier 6 Tesla tower. And the way the Tesla tower works is you send power to it, and then the Tesla tower sends power to any machine that has a Tesla coil cover on it. You could, in theory, put these covers on each machine and then have the Tesla tower output power straight to the machine. However, you do need to be careful about voltages because the power that's output will be at the voltage of the Tesla tower. So in my case, it would be LUV power. So I can't directly power an HV machine with this. I would have to power a transformer, and then the transformer would transform down into HV and power my machines. That's one option. The other option, which I think is what I'm going to go for, is I'm going to remotely power local buffers. So I'm going to set up a Lapatronic supercapacitor wherever needed, and I'm going to Tesla tower the power over from the main power building to the local buffer. And then locally, I'll just use cables. I think that's fine. If you have multiple Tesla towers of varying voltages, you're going to have a lot of explosions because you can't control which Tesla tower sends power where, at least not easily. So my plan for now is I'm going to use cables to bring power from the various power sources into the power hub. And then from the hub, I'm going to use the Tesla tower to transport power to power sinks. Making the Tesla tower is not too difficult. It's a little expensive, but at this point everything is. I've already made all of the blocks except for the controller itself. The most pricey thing here was probably this gobbles up a lot of mica. Also uses up quite a bit of superconductor wire, and this is all LUV. I also made some LUV Tesla capacitors. These are needed in the capacitor hatch, and I'll explain that later. But now all that's left to do is to make the actual controller block and set it up. As you can see, I put a little sheath around this Tesla tower because, to be honest, I did not really like what it looked like. But I thought it'd be fun to put it on its side, just for fun, and this power building looks a lot cooler now, I think. But if you look at it from a certain angle, the Tesla tower's capacitor hatch I filled with 16 LUV Tesla capacitors, and this is being fed with 16 amps of LUV power, just from this cable from the main storage buffer. And to test that this works, I've built another Lapatronic supercapacitor in my blasting hall, one of my 2 blasting halls. This is going to be my power source for the blast furnaces, because I need to upgrade these. Half of these are still in IV. Some of these are in LUV, but with like transformers and stuff, it's a mess. So I want to upgrade all of these things, and I also want to replace some of these with Vulcani. because that's a good next project, this would be a good place to put the Lapatronic supercapacitor. So to test, we've got the 16 amp dynamo hatch pointing down and a 16 amp energy hatch over here pointing up. I guess the dynamo hatch is not really relevant, but the energy hatch apparently needs to point up because the Tesla coil covers don't really like when they don't point up. Now, as soon as I put this Tesla coil cover on, nothing should happen because the Tesla tower is off. But now we can see that the supercapacitor is at 0%. Let me go turn on the Tesla tower. And when I do this, I hope I don't hear an explosion. Ooh, I hear a cool sound effect. It's really quiet. However, as you can see, the power is not going up in the supercapacitor. That is because you need to set the transfer radius to something higher than the base value of 32. And you need to set, I think it's this one, which is the output current setting. Current here meaning like amperage. So I set it to 16 because I have 16 capacitors, so I can do 16 amps. And now my base is going crazy. It's pretty cool. It's a little distracting, but do not be alarmed because HamCorp has taken every possible safety measure, which is like nothing. And now our supercapacitor is charging, and this value is pretty much 16 amps as expected. So I don't know if I'm gonna keep this, all of this on all the time. I believe you can turn off the lightning, but I'm gonna leave it on just for a little bit. Now I would like to upgrade a lot of multi-blocks around the base to LUV. Specifically my blast furnaces, but also stuff in my chem line. LUV energy hatches need ultra high power ICs, which needs molten naquadah. And so far I've been getting my molten naquadah from extracting nuggets, and the nuggets I get from this really bad blast recipe. This throws away all of the byproducts, so obviously this is not good. But to do the full naquadah line, I need a new multi-block. 2 multi-blocks actually. The first is the neutron activator, which looks like this. I don't know how this thing works at all, but we'll find out later. Because to make the controller itself, I need another multi-block, which is the precise assembler. And the precise assembler is basically a multi-block assembler. So that's nice. I can start phasing out my old assemblers. To make the precise assembler controller though, I'm going to need these high computation stations Mark 1. And these need ASOCs, Advanced Systems on a Chip. And this needs naquadah. Naquadah doped wafers. And the naquadah doped monocrystalline silicon boules are made with naquadah ingots. So I'm gonna have to get by with this little nugget method for a bit longer, but I want to start going towards making the naquadah line. As a first step, I'm gonna go for finishing up this little branch of quests in IV. So first I need to make a naquadah ingot, and then the silicon boules, a lot of wafers, and then I can get the ASOC. But also I can get regular SOCs. And these regular SOCs are used in the best recipe for LV and MV circuits. These are the cheapest possible recipes in a single block circuit assembler. I'm also going to have to smelt some osmiridium for the precise assembler, so I'm going to do that as well. Okay, at this point, we could make the precise auto assembler. Before I said it's a multi-block assembler, but I think there are 2 different multi-block assemblers, and I don't know exactly what the difference is. I think this might be a little more specific in its use, but I think what I was thinking of before was actually this one, the large-scale auto assembler. This looks more like a classical like GT++ multi, just a cube. So I kind of want to make both of these. This just to speed up my, my assembly recipes. The precise one for progression. To be specific, for the precise auto assembler, I don't want to use these imprecise electronic unit casings. I actually want to use these ones, at least. The precise Mark 1s. The neutron activator controller block, this specifically says it needs Mark 1 casing. I imagine this means at least Mark 1 casing. So to get started, I do want to make the multi-block assembler before continuing, and then I'll make the precise assembler. Never mind, I can't make this. It needs tritium naquadah carbonite, which I definitely cannot make. So this is going to have to wait a little bit. Okay, precise auto assembler. Back with an update. I'm still working on the precise auto assembler and the Mark 1 casings, and I'm currently stuck on 3 things. So first of all, I need some phosphoric acid. This is easy. I just need to set up a chem reactor to start generating this. Just wanted to show you because this is the recipe I'm going to be using. There's a couple other recipes, but I think I have both apatite and phosphorus pentoxide set to automatically electrolyze. Second, the MAR CE M200 steel ingots. The MAR M200 I think is not a problem. The cerium is also not a problem. The lithium chloride is not a problem, but this craft is a ZPM craft. So I'm going to need 2 LUV hatches. I don't think I'm going to automate this. I'm just going to batch craft a bunch of these MAR CE M200 ingots for now. And then once I have ZPM hatches, I'll teach the recipe to a dedicated ZPM blast furnace. And finally, Sonarium. I mentioned this a while ago as something I wanted as part of when I was doing the nuclear stuff. I mentioned the Sonarium fuel rods. You get Sonarium fuel rods from using glowstone fuel rods, but I don't really want to do that because there's this much simpler recipe that's way more expensive in terms of energy, but I only need 4 Sonarium for now. It uses UU matter and glowing coral. UU matter you've seen before, we have some, but glowing coral, I think I got lucky a long time ago and I actually got some seeds. And I am currently, very slowly, I see that something has died here, so currently not propagating this one seed that I have. Once I fix this, I'm going to have a nice big batch of glowing coral here, and I'll set up a farm, and then we have infinite glowing coral. And that also means infinite Sonarium, but that energy cost, man, that's a lot. I'm going to do this for now, and in the future, I'll set up a nuclear reactor for glowstone fuel rods. Ooh, actually, lithium chloride is a little difficult. I didn't expect this. So the only way that I can get lithium chloride, I think, is getting the dust from this recipe. Putting purified lepidolite into a chemical bath with hydrochloric acid. I don't see any other way that I could really get this. Maybe this blast furnace recipe with brown algae biomass, but I'd have to build an algae pond for this, which might not be a bad idea. But I only need a little bit. So, I'm gonna have to change how my ore processing is set up for the lepidolite. That's kind of annoying. I don't think I have any unprocessed lepidolite, so I'm gonna have to go mining or set up a miner. I have thrown this thing together. It is not that complicated, honestly. The one thing to watch out for when you're building this is that you need to use IV machine casings in here because it limits the maximum hatch tier, and I'm using an IV energy hatch. So if you want to use an IV energy hatch, you need IV casings. Besides that, it's just a regular build, I guess. Here I have a quadruple input hatch because a lot of recipes use 4 fluids, and I have a dual interface with a fluid P2P setup. I also have the mode set to precise mode because this is going to be a precise assembler, not a regular assembler. Along the way, I had to make some elite circuit boards, so I made some extra to finish the quest. And now to make the neutron activator, it's just a matter of making these parts. We do need to make the Mark II high computation stations, and these are also a precise assembler recipe. But all the parts that go in are things we've seen before. However, this is an LUV recipe, I'm just now noticing, so actually the IV machine casings need to be swapped out for LUV, and I need to put in an LUV energy hatch. Well, besides that, pretty straightforward to make the controller block. By the way, I used a Metrix transmitter cover to relay the information from my main power storage to here. And this is just an advanced information panel, same as what we have here for the miners. But I've angled it like this, and I found that you can make it transparent. But it's a little hard to read. I do like the idea of it being transparent and then having kind of a screen somewhere, but I don't know where to put it so that it doesn't also obstruct the wonderful view. So for now, I just have it as a little screen over here. Anyway, neutron activator. One thing that is slightly different about the neutron activator is that it uses a neutron accelerator instead of an energy hatch. And this means I need to do a little bit of math to figure out what tier I need, or at least see if there's some way I can use redstone logic to turn on or off the neutron accelerator. So I've been looking at how the neutron activator works. By the way, it says superluminal velocity motion. No. So the way this works is the neutron accelerator consumes a certain amount of EU per tick and then converts that into neutron kinetic energy in electron volts, which is EV. So 1 EU gets converted to between 10 and 20 electron volts, and I guess it's a random number in that range. The more energy you put in, the faster this multi-block gets up to the minimum required energy. So obviously the LUV neutron accelerator would be the best for me, and I can make almost everything here, except the argon gas. Argon gas is kind of more effort than I'm willing to put in at the moment, so I'm just going to settle for an IV neutron accelerator. When I eventually want to upgrade to LUV, I still need to scan an IV one, so I will need one anyway. But the IV neutron accelerator uses 6,500 EU per tick, which gets converted to 10 to 20 times that in electron volts per tick, which is about 1.3 to 2.6 mega electron volts per second. If you assume it's just the average, then it's about 2 mega electron volts per second. The first time I used this multi-block is in this recipe, the naquadah adamantium solution getting turned into some other stuff. And this needs between 200 and 230 mega electron volts to function correctly. So we don't want to go above 230, that'll start voiding things, and we don't want to start this below 200. Because that will also start voiding things. So it's going to take about 100 seconds to get up to speed. And then if we leave the accelerator on, we have about 15 seconds worth of time before we cross this maximum kinetic energy. So we're going to want to do like a latch thing, kind of like what I do with the power building, so that when it's below a certain energy, we turn on the neutron accelerator, and then once it crosses 80% of our maximum, it turns it off. If you want to be extra efficient, you don't want the neutron accelerator to even run if there's no craft pending. So I think I'm also going to try and account for that. One important thing is that the multi-block will explode if the neutron kinetic energy is over 1200 mega electron volts. Some of the recipes go up to 1100, so something to think about. Also, it's not really possible to use the same neutron activator for multiple different crafts in the naquadah line because a lot of them need pretty different kinetic energies. This one needs 460 to 480. This one needs 1050 to 1100. This one needs 200 to 230. So I pretty much have to make a new neutron activator for each one of these steps, unless I'm missing something. Cool. Today, I think I'm just going to set this up somewhere. Actually, I think I'm not even going to do that. For now, I'm going to figure out where I want to put the naquadah line and build a big space for it. And then in the next episode, we will actually look at the flowchart. Oh my god. I love warp. But in the next episode, I will look at the processing line for naquadah and also try to implement it. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will go over the processing line for naquadah and set it up. We will also cover neutron activator automation. HamCorp would like to once again remind employees that as part of your contract, HamCorp is not legally responsible for any bodily harm an employee may suffer due to electrocution, immolation, explosion, implosion, suffocation, malnutrition, drowning, or termination. See you next time.